Hey, what's going on, guys? Let's draw the Lewis structures for these molecules right here. So let's begin with this VH3. The first thing we have to do is we have to calculate the total valence electrons. So let's calculate it. VH3 for boron it's 3 valence electrons. So the total valence electron is going to be 3 plus, and each hydrogen is going to have 1 valence electron, right? So 1 times 3, and if you calculate all of them together, that's going to give you 6. Now we have to draw the diagram. Diagram is going to be, so we are going to have 6 electrons. Let's connect the bonds first. So hydrogen only can have one bond because the maximum electron hydrogen can have is 2, right? So each hydrogen is going to have one bond right here, like this, and we don't have anything else. 6 electrons are finished, and this is going to be the structure. For boron, it's an exception for octet form because all the atoms try to have 8 electrons around this except hydrogen, because hydrogen can only have 2. But boron, in boron's case, it can be satisfied with 6 electrons. So this is going to be the structure for this one, and the molecular structure of this one is going to be trigonal planar, since we have only three connections, like 3 groups. This is 1 group, 2 groups, 3 groups, right? So the structure is going to be trigonal planar. So this is going to be the molecular geometry. And let's calculate the formal charge. To calculate the formal charge, we have equation, that is valence electron. So we are going to calculate for central atom, right? So central atom valence electron times 1 times the dots. So there's no dots right here. Dots mean the lone pairs. We don't have any dots. So we don't have any dots. We have 3 bonds, 3 valence electrons. So it's going to be 0. So we don't have any charge right here. So let's look at the water. So let's take the H2O, and if we calculate the total valence electron, what's going to be 2 times hydrogen, so 2 times 1, and we have 6 valence electron for oxygen, so that's going to be 2 plus 6, 8, right? So this is going to be the valence electrons. Let's fill it up. Oxygen, and each hydrogen can only form one bond because the maximum amount of electron hydrogen can have is 2. So this is going to be H right here, H right here, and we have filled up 4 already. We have 2 left. So due to these 2 lone pairs, this is going to pull this hydrogen down. So that's why this is having this shape right here. So this is the shape of this one. This is called bend shape, right? And if we don't have any lone pair, this is going to be a straight line. Since we have lone pair right here, that's going to pull these atoms down, and that creates the bend shape. And here the angle it's going to make is 104.5 degree. That we have to memorize that one. So there's no logical explanation for this one, and that is the angle that makes. So we have drawn this diagram, and this is molecular geometry, right? This is molecular, and that's the electron pair geometry too. Electron pair geometry, that depends on how many groups of things we have, like 1 bond, 2 bond, and 1 lone pair, 2 lone pair. So the total groups we have 4 groups right here. 1, 2, 3, 4, right? If you have four groups, that called tetrahedral shape. So when we have 4 groups, that is always tetrahedral. So this is the electron pair geometry. And what else we have to do? We can calculate the formal, like the charge. The charge for the central atom is going to be valence electron minus bond times bond plus the dots. So here what is it? Oxygen has 6 valence electron, 6 minus bonds, 2 bonds plus 4 dots, so that's going to be zeros. That's why we don't have any charge right here. So let's look at the third hydronium ion. So let's write this one right here. Hydronium ion H3O plus. Let's calculate the total valence electron. So this is hydrogen is going to have 1, so we have 3 hydrogens right here, so this is going to be 3 times 1 plus oxygen is going to have 6 valence electrons, 6, and whenever we have a plus sign, that means minus 1, right? If it's plus 2, it's going to be minus 2. Like whatever plus we have to deduct this one from the total valence electron. So here we have 3 plus 6, that's going to be 9, 9 minus 1, that's going to be 8. Let's draw the diagram. So we have hydrogen right here, hydrogen, hydrogen. So we have 6 filled up and 1 lone pair, right? Due to this lone pair, this is going to push these atoms down, and we have this shape right here. And this shape is called, if you imagine, this is going to be a pyramid shape, right? So this is called trigonal pyramidal. Trigonal pyramidal, right? Pyramidal, and this is molecular geometry. And as we seen this like this electron pair geometry, if you see, we have to see how many groups it have. We have 1 lone pair, 1 bond, 2 bond, 3 bonds. The totally 4 groups are right there, right? So the electron pair geometry is going to be tetrahedral. So whenever we have 4 groups, that's always tetrahedral, right? So that's going to be the electron pair geometry. And if you want to calculate the charge, this is going to have, since they have provided plus right here, we have to write a plus right here, right? So if you calculate the charge, you will get plus 1. Let's see. So formal charge is going to be equal to valence electron minus bond plus dots, right? So valence electron of oxygen, we are always looking at the central atom, right? So oxygen is 6 minus the bonds it's forming 3, and the dots we have is 2 plus 2, and 6 minus 5, that's going to give you plus 1. So that's how we got this plus right here. And let's look at another one, OH minus hydroxide. So that's gonna be, so we are going to have OH minus, the total valence electron 6 plus each hydrogen has 1, so we only have 1 hydrogen, so this is going to be just 1. And whenever we have a minus sign, we have to add 1. If it's plus, we have to subtract 1. If it's minus, we have to add 1. So that's going to be 7, 8, right? Total 8 electrons. And let's see how the structure is going to look like. O dash H, and we have 2 gone already. We have 6 left. That's going to be filled up with oxygen, because hydrogen can only have 2 electrons maximum. So this is going, 6 are going to be right here, and this is linear shape. Linear shape, right? The molecular geometry is linear shape, and if you want to calculate formal charge, you will get minus. Since we have minus provided, let's calculate the formal charge. Valence electron minus bonds plus dots, right? So oxygen is our central atom. Oxygen has 6 minus 1, bond is 1, and 6 lone pairs, 6 lone pair electrons. So 1 plus 6, 6 minus 7, that's going to give you minus 1. So that's how we got this minus 1 right here. And that's all about it. I hope you guys find this video helpful. Thanks for watching.